So now if you provide a voltage difference, the electrons within the metals of the wire, they will start to move, then they form the current. So you see, the movement of the electron still plays a very crucial role. And when the electron is moving, they will meet a so-called resistors. So the resistor is a device trying to stop the movement of the current. So in order for the charge to passing through, they have to give the energy away as a heat. So once they give away as a heat, they will move continuously passing through the resistors. So now we can connect the three concepts together: the voltage, the current, and resistance. And the relation between them is the so-called Ohm's law. So we find out in the experiment is that the current in the circuit varies, and it is directly proportional to the voltage difference, but inversely proportional to the resistance. So I is equal to V divided by R. So therefore, the famous Ohm's law can be written in terms of V equal to I times R. So this is the Ohm's law. Now let's try to study that circuit. So you already learned what is the meaning of a current and a resistor. So now if you have more than one resistors, for example, you have 3. So now if you put the 3 together in this structure, we say this is a series circuit. So what is a series circuit? It means that the current passing through each device is the same, but the voltage is not the same. And there's a concept of the total resistance of the 3, which is the so-called total resistance. So the total resistance is the summation of the individual 3 resistors. Okay, and apparently the more resistors, the less of the current, because the more resistance means this one is bigger. But the voltage is fixed. Yeah? The voltage source is from the battery here. So this value is fixed. So the bigger the resistance, the smaller the current. So I hope now you have a sense of feeling what is the series circuit. And now the second device is the parallel circuit. What is the parallel circuit? You still attach the 3 resistors to the battery, the same battery, but in different order. In this case, the voltage across each resistor is the same, but the current is different. So the total resistance of these 3 resistor combination will be smaller than the individual one. You see, it is very different from the value here. The total resistance adds up here, but here the total resistance is smaller than even for the individual value. However, the total current is the summation of the individual 3. So the current will flows out, and at this point, they have 3 branches. So the current will split into 3 components and combine together at this point and going back to the battery. So this is the parallel circuit. And this 2 circuit is a very important concept in these chapters. And now let's go to the chapter 9. So we are studying about the magnetic field. So magnetic field has many similarity with the electric field. For example, we have 2 opposite sides of the magnetic poles, which is north and south pole, and the same sides of the pole repel each other, and different sides of the pole attract each other. And the difference compared with the electric field is that you never can observe a separate north or south pole. They always appear in terms of pair. But the force actually behave very similar to the electric force. So the strength of the interaction depend also on the distance. So the further away the 2 poles means that the smaller the force it will be. Then we introduce the concept of the magnetic field. So what is a magnetic field? It is the magnetic force per magnetic poles, similar to the previous one. And now we can also use the field lines to demonstrate and visualize the magnetic fields. So the concept of the magnetic field is also very similar to the electric field. So the direction is the convention. The magnetic field lines always comes out from the north pole, and they always end at south pole somewhere. And based on the density of the magnetic field lines, it can tell you how strong the magnetic field it is. So the density also determines the magnitude. exactly the same concept. But now it all comes to a very important concept, but it is usually the part the student will have a little confused, is that the interactions between the current and the magnetic fields. So I'm going to introduce you the two right-hand rules, and this will be the first one. So any moving charge will produce a magnetic field. So let's assume that the current is moving upward. So now the right-hand rule is the thumb is the directions of the current, and you curl your fingers, 4 fingers around. So the 4 fingers tells you about the directions of the magnetic field. Okay, so this is the first right-hand rule. So if you reverse the direction of the current, the direction of magnetic field lines also will be reversed. So this is very important. And now if you put a long wire current within the magnetic field, then there will be a force acting on the long wire. And this force is also determined by the right-hand rules. So the thumb will be the directions of the current, and the 4 fingers will be the directions of the magnetic field, and they should be perpendicular to each other. And the force will be in the direction perpendicular to the direction of the current and the direction of the magnetic field. So this is the second right-hand rule to determine the force acting on the long wire current. So if you try to look at in terms of diagram, this is the force. So if you know that you have a moving charge moving in these directions, and you also know the direction of magnetic field. So how you determine the direction of the force is that you use the 4 fingers as the directions of your current or the moving charge, and they will bend toward to the directions of the magnetic field as I teach you in the class, and the thumb now will be the direction of the magnetic force. So magnetic force depends on the direction of the charge and the direction of the B field. And most important thing is that, did you notice here, the magnetic force is always perpendicular to the directions of the charge. So which means the magnetic force will only change the directions of the velocity. They will not change the magnitude of the velocity. This is so important. So let me emphasize again. The magnetic force acting on the charge, they only change the directions, but not the magnitude of the velocity. And now we study that we find out if you try to change the number of loops in the coil carrying the current, so you will find out that if by changing the number of the current there, it can produce an induced EMF. So which means that either change the magnetic field or change the electric field, they will produce each other. And people find out in the experiment is that if you slow move the magnetic field, they also will produce the voltage difference. If you move the magnetic field rapidly, they will produce a bigger voltage difference. So what happens is this, the Faraday's law. So this induced voltage in the coil is related to the number of the loops multiplied by how fast the magnetic field is changed with respect to time. And the magnitude of the induced current is determined by the Ohm's law again, because now you can find out the induced voltage here. So the induced current is determined by the induced voltage divided by the resistance. And now we can apply this concept to the transformers. So what happens in the transformer is that you have a primary coils and the secondary coils. So in the primary coils, you attach to a loop of a current. So this loop of current will produce a magnetic field, and this magnetic field will passing through the secondary coils. So if the magnetic field produced by the primary current is different, is changing, then they will produce an induced EMF and induced current in the secondary coils. So which means that by determining the number of the loops, you can change the voltage from primary coils to the secondary coils. And this is the so-called transformer relationship. So the primary voltage is Vp, and the number of the primary terms is Mp. So now this relation can be rewritten in terms of this. And you will find out by control the number of the loops or the terms, you can determine that you can increase the voltage or decrease the voltage. And that is how the transformer is designed. Now let's go to the chapter 10. So when we try to study the concept of wave can be described by a frequency, speed, amplitude, and wavelength. But what is the frequency, speed, and amplitude, and wavelength? So let's focus on the wavelength first. So if you look at the pattern, this is the so-called transverse wave. So the wavelength is the distance between the two crests or two troughs or any 2 points which repeat itself. So now if you have this waveform, then you can define what is the wavelength. Okay. And now the wave speed is that how fast this wave will be propagate to these directions. So wave speed is written in terms of the product of the wavelength multiplied by the frequency. So you may ask, what is the frequency? So frequency is actually 1 over the period. So the period is the time for one wavelength to pass a given point. So the time for the wave to pass from this point to here, okay? So this is one wavelength. So for this one wavelength to pass to a specific point, the time span is a period. So the frequency is 1 over the period. And the wave speed now is described of the product of the two values. And we know that the wave can be categorized in two ways. One is the longitudinal wave, the other one is the transverse wave. So the example for the longitudinal wave is the sound wave, because it is due to the compression or rarefication of the air molecules. And we know that the speed of the sound wave is 340 meters per second in the air at a temperature 20 Celsius. So actually the speed of the sound wave depends on the temperatures. So therefore, if you increase the speed of the temperature by 1 degree above the 0 Celsius, you will increase the speed of sound wave 0.6 meters per second. So the higher the temperature, the faster the sound will propagate in the air. So that's the reason if in the warm air, they will have even bigger than the 340. So please remember that the speed of the sound wave depends on the temperatures. And also it depends on the material, the density of the material. So you can see that when the sound wave is propagated in the steel, which is more dense than the water or in the air, they will travel 15 times faster in the steel. So the temperature and the density of the material will change the speed of the sound wave. And as a wave, they all have the same phenomenon. One of them is reflections. So what is the reflections? It means that when the wave, this is the direction of the wave, interact with the surface, they will be reflected. And now the angle of the incident angle, theta r here, compared with the normal line, is equivalent to the reflected angle, which is these ray directions compared with the normal line. So this is the direction of the reflected ray. So all the wave will follow this law of the reflections when it is reflected. And another rule is the refractions. Now the difference is that now the wave can propagate into that material. They will not be reflected. However, because they can enter into a different material, the speed of the propagation of wave is different. So therefore, the wave will be bended. So for example, if it is a light, the light will be bended when they may enter into an area which is the density is higher. So this kind of refraction of the wave is a so-called refractions, and it is described by the Snell's laws.